It's Kristine Davis, and I work at Johnson Space Center. Actually from Kansas originally. I grew up in a town called Galva, Kansas, which is right next to McPherson, about an hour north of Wichita. So growing up there, my parents definitely encouraged me to explore different STEM career options, so science, technology, and engineering and math. And one of my favorite places to go was the Kansas Cosmosphere. I love going there in the summer and also attending some of their camps. While I was in one of their camps, I got a chance to come down to Houston and come see Johnson Space Center. I think I was about to go into my freshman year of high school. And that experience really inspired me to want to do something to impact NASA, to be able to work there and be able to help with the mission of space exploration. So I decided in high school that I wanted to be an engineer. I went to Kansas State University, where I got my bachelor's degree in mechanical engineering. While I was there, I did some internships, both for private companies that work in the space industry, United Launch Alliance, or ULA. They launched the Atlas and the Delta rockets, so did a couple internships with them before I got into the NASA's Pathways intern program and did some internship rotations down here at Johnson Space Center and got introduced to spacesuits and how they work and the design. And so from there, I got hired on full-time after I graduated in the spring of 2016, and I've been working full-time ever since.
That is so cool. Well, thank you so much for being here today to share what you and I both love, because we're both engineers and we love figuring things out and just trying to, do what we can, and also inspire the kids, because we have a lot of kids, as you know, who watch the Discovery Center and things that we do. So without further ado, we'll get your presentation up and we'll let you tell us all about it.
Awesome. Great. So I'm going to go through spacesuit design. I'm going to talk to you about why do you need a spacesuit, how spacesuits are constructed, the spacesuits we've had in the past, our current spacesuit, and then some designs for the future as well. So this is just another introduction slide, more about my information. So again, from Galva, Kansas, and I went to Kansas State University, and this is a picture of me whenever I got to come down to Houston for space camp, going into high school, and decided that engineering is a career that I wanted to pursue. So you want to build a spacesuit. So the first two things that you need to know are, where are you going to be going and what will you be doing when you get there? These first two questions is really where we start whenever we're trying to pick and design a spacesuit for any mission. So if you're designing a spacesuit to go to the International Space Station, which is our laboratory that is in low Earth orbit, orbiting around the Earth every day for the last 20 years, if you want to go there, your spacesuit design is going to be a little bit different from microgravity versus if you're going to the lunar surface. Spacesuit microgravity, a big difference between a lunar or planetary surface is you don't have that gravity. It's microgravity there, so you're floating around. So you don't need legs to be able to walk, to transverse. You're going to use your arms and your hands a lot more. Versus a lunar planetary surface, you have to have more mobility because you need to be able to walk better. You're also going to be dealing with different environmental conditions. It's going to be really dusty there. And then you do have some gravity to take into account, 1/6 of the gravity here on Earth. So whenever we're looking at spacesuit design, these two questions of where are we going to be going and what will we be doing when we get there really drive a lot of our design trades that we make. When you think of spacesuits, think of them as human-sized spacecrafts. So again, I talk about the International Space Station, or the ISS, that's orbiting above us right now, and we have 6 people living and working there every day. Everything that we need to keep those people alive and keep them safe when they're up in space, they have in that International Space Station, which is that orbiting laboratory. We condense that all into a small space for the spacesuit whenever they go out on an EVA, or an extravehicular activity, which is what we call a spacewalk. So you still need all those things to keep you alive and keep you happy and safe, and it's just condensed into a smaller package. And it can keep you alive and out doing a spacewalk for about 8 hours. So everything you need here in your space station, you also need in your spacesuit. So when we think about spacesuits, we think about them as life support systems and as human-sized spacecrafts. So why do you need a spacesuit? Well, there's lots of dangers whenever you're going out into a vacuum environment. There's temperature extremes. It can be really cold or really hot, depending on if you're in the sun or in the shade. Oxygen's a big deal. You need oxygen to be able to survive. You also need air pressure around you. Several of our organs are designed to work at air pressure. Right now, at sea level, we're under about 1 ton of air. So when you think about it, our bodies are designed to be in this kind of this ocean of air around us. We also need to protect against micrometeoroids. These are things that could hit your suit and possibly damage them. And then radiation. So I'm going to talk about each of these different hazards and how we protect against those in a little bit more detail. So starting off with protection from extreme temperatures. So outside the International Space Station, temperatures can range from negative 250 degrees Fahrenheit to positive 250 degrees Fahrenheit, depending on if it's in the sun or if it's in the shade. And there's 2 ways that you can transfer heat in space. There's conduction, which is 2 objects touching, and there's also radiation, which is heat waves from the sun that get absorbed. So the way we keep our astronauts safe is we keep that outside temperature from getting to the inside of the suit. This is through multi-layer insulation, what we call MLI, and we use lots of layers of fabric to create gaps between the fabric that limit our conduction and also help with reflecting that radiation or that heat away. That's also why our spacesuits that are used for EVAs are white, because the color white reflects all the heat. And so that does a really good job of making sure our astronauts stay nice and cool and safe inside their suit. So this is a picture of all the different layers of spacesuit insulation that goes into your outer garment that keeps you safe. So while we do a really good job of insulating the suit and keeping all those extreme temperatures from not reaching the person inside, we also have to condition the suit inside to keep the crew member cool enough. Because as you can imagine, if you go out on a hot summer day with a sweatshirt on, with sweatpants on, lots of layers of clothes and start running around, you're going to get really hot really fast. And so we need to make sure that we cool the crew members well enough. So the way we do that is underneath their spacesuit, they wear a liquid cooling and ventilation garment, or LCVG. This LCVG conditions the interior of the suit, and it cools through conductive heat transfer. So this LCVG, which is a picture of it right here, it's conformal to the body, and it has over 300 feet of tubing that's woven into the garment that helps pick up, that water runs through, and that helps pick up the heat that the person is generating. This water is supplied by the backpack of the suit or the portable life support system. And then also we have vent tubes that remove the moisture. So that way you don't get too clammy inside your spacesuit. It doesn't get too humid in there from working, because you're working hard whenever you're going out on a spacewalk. So we want to make sure that our crew members don't get too sweaty. So I talked about the hazards from the temperature and how we protect against those. We also have protection from micrometeoroids. So micrometeoroids are small objects. So a micrometeorite could be anything smaller than this quarter. It could be a fleck of paint from a previous satellite or a small piece of debris that's up there orbiting around Earth. And we need to protect against those if they accidentally hit the spacesuit. So the problem is kinetic energy. So the formula for kinetic energy is 1/2 times your mass times your velocity squared. And that velocity squared is why it's so important to protect against micrometeorites. It's because the energy from the particle can be transferred into the suit with that kinetic energy formula. And because you square that velocity, and we're going at 17,000 miles per hour, even a very small mass could really hurt your suit. So we actually use the same multi-layer insulation that we saw in the previous picture to protect against thermal. We use that also to protect against those micrometeoroid impacts. And that's because all those layers of fabric create a shield for the suit. And so if anything hits it, it gets broken apart by all the different layers, so it doesn't get to the pressure bladder, which is what's holding the air into your suit, and that keeps you happy and alive. So we protect against thermal and also micrometeorites. We also need protection from vacuum. So vacuum means that there's no air to breathe. So whenever you go out on a spacewalk, you don't have any oxygen out there. So we need to be able to provide that to the crew member. Humans will lose consciousness in seconds and die from hypoxia in minutes without oxygen. And the lungs also cannot function without a pressure differential across the diaphragm. So you not only need oxygen, but you also need air pressure around you. There's also a direct relationship between the boiling point of water and atmospheric pressure. So here is a temperature pressure curve. So we have pressure here at the bottom and the boiling point of water here on the side. So you can see as right now we're about 100 kilopascals is about what you're at sea level, and the boiling point of water is about 100 degrees Celsius. And as you drop that pressure, you're going to drop the boiling point of temperature to about 20 degrees Celsius, which would mean that's about the temperature of what your body is at room temperature. So spacesuits provide that stable pressure environment, kind of similar to a balloon that contain the oxygen that is supplied by the portable life support system. So we not only need that oxygen, but we also need that pressure. We do operate
Hey, Chris, we had a question come in.
Yes.
So you're talking about everything that protects the body from space. And we had a question come in through Messenger that asked if you still have to wear gloves and boots, because if we're just talking about breathing and things like that, is it important to wear gloves and boots still in addition to the rest of the suit?
Yeah.
Also, we noticed that the McFarland kids are watching. So hi, friends. Thanks, everybody, for tuning in. Kristine is telling us all about the spacesuit. It's so much fun. So yeah, do we have to wear gloves and boots to protect us in addition to the rest of the suit?
Yeah, that's a great question. So we do need to wear gloves and boots. We are able to protect our hands from those temperature extremes with those gloves. Those act kind of like oven mitts for us. Same with our feet. We need to protect those from those temperature extremes. And also by having that full suit system where you have gloves and boots and legs and torso and arms, you create this kind of similar to like a big balloon that's human shaped. And by having that balloon-like structure, you can pressurize it and give the air pressure and also the oxygen that everybody needs. And if we have some time at the end, I do have some cool videos about some vacuum chamber tests that was done previously that kind of explains, again, the importance of having oxygen and also pressure in your spacesuit. So in space, we also protect from radiation. We limit the exposure of alpha and beta particles from reaching the astronaut by use of the helmet visor, and also, again, by having our spacesuit be white. And then we also limit the lifetime exposure so that we make sure that astronauts don't have too much radiation over their career. So those are all the different hazards. So we talked about micrometeoroids, thermal hazards, needing oxygen and pressure, and also protecting against radiation. So those are all the things that we need to design our spacesuit to help protect the astronaut and help keep them happy and healthy to be able to do their spacewalk. To do that, we have our general spacesuit construction. So when we talk about a spacesuit, we're making up of three main different components. And the first is the soft good layers. And so this is what you think of with the fabric parts of the spacesuit. So underneath all that fabric, because you were used to seeing the TMG, which is that thermal micrometeoroid garment that I talked about before. And that's the white outermost layer that we see covering the whole spacesuit. Underneath that, you have a restraint layer. That layer is sewn, and it helps to take some of the pressure away and help support the bladder layer. The bladder layer is that balloon-like structure that helps keep all the air inside your suit, and is probably the most important layer of your spacesuit. So all those different layers stack up on top of each other and create that soft good joint. So we use those for the gloves, the arms, the legs, and the boots. We also have metallic components, so these connect all those different pieces together. So there we have bearings and connectors that help our suit be able to be modular, so you can mix and match different components. And then finally, we do have composite structures in the suit. So this is fiberglass material that's then covered by a TMG, and that helps to make the suit a little bit more robust and also have more rigidity to attach things like your portable life support system. So past spacesuits. So NASA has been building spacesuits really since the beginning of our manned spaceflight programs. We have the Mercury and Gemini programs. So these two suits were mainly based off of Air Force and Navy high altitude pilot suits. With the Mercury suit, this suit was just made for inside your capsule. That's called Intravehicular Activity, or IVA. So this just protects the crew member in case their capsule would lose pressure. In Gemini, that was the first time we went out the door, first time we did a spacewalk. So this suit was designed for both in your vehicle and also outside doing your spacewalks. Apollo, that's the spacesuit that is very iconic for NASA because that's the spacesuit we used to go to the moon on the first time. So with the Apollo spacesuit, this, like the Gemini and Mercury suit, you wore in your capsule and also for that EVA, for that spacewalk. But this suit was also the very first one where it was independent of the spacecraft. So with Mercury and Gemini, you can see here in the picture on the middle, on the bottom, there's these umbilicals that run back to the vehicle. So the vehicle is supplying all the air pressure, all the carbon dioxide scrubbing, everything that you needed to do your spacewalk. But for Apollo program, we instead have a backpack on the back of the suit, and that has everything in there that they need to stay alive. So then there's a big architecture.
Kristine, we have another question for you. Yeah, sorry, we have another question for you. So we have the Dennett's washing also, but we have a couple questions. One from Rick. He said, how much air do you get in your spacesuit? And then the McFarlanes asked, do you feel like a marshmallow? So we're talking about what the suit feels like and then how much air is actually in the spacesuit.
Yeah, that's great questions. So I don't know the exact amount of like air calculations for how much we need to provide, but I do know that we pressurize our suits to 4.3 PSI absolute. So right now we're at 14.7 PSI absolute here and PSI stands for pounds per square inch of pressure here at sea level. So we do operate our suits at a lower pressure, and that's also why we need that 100% oxygen. And so to do that, we have oxygen cans that are in our portable life support system that are pressurized to 3,000 PSI or pounds per square inch. And so those 3,000 PSI oxygen bottles provide us the oxygen we need for our spacewalk for that 8 hours. And then as far as feeling like a marshmallow, so it does feel, you are wearing something that's bigger than yourself. So it does feel different than kind of any other experience. And also the suit's pressurized. So think about whenever you have those long, skinny balloons that you can make into balloon animals and how the more air you put into that long, skinny balloon, the harder it is to bend. The same thing happens with our suits. So we are pressurizing this 4.3 absolute, and so you're moving against that pressurized garment. So it takes effort to move and to try to do any kind of task. So it's a very, we almost call it like a sport whenever you go out and do a spacewalk. It's a very physically intensive exercise to be able to go out and do a spacewalk.
Very cool. While you're on this subject, we had two more questions come in. You were talking about the tank and how long they can be out there. Daniel asked, how long would the air tank be effective? And then Barbara asked, does the suit feel very heavy? You talked about, the outside and how it feels, but does it feel heavy?
Yeah, that's a great question. So the first question is, our oxygen tanks are designed for about that 8-hour EVA, plus there is contingency time built in there too, just in case. And we do have secondary oxygen tanks in case your primary would lose pressure. And that secondary tank can get you, depending on what your emergency situation is, can last anywhere from 30 minutes to an hour. Those secondary oxygen tanks are also designed to be at a higher pressure in case your suit were to develop a hole. We could sustain a leak to be able to get the crew member back inside safely. As far as how much your suits feel, if they're heavy, so that depends on where you're at. So if you're, for example, at the International Space Station, there you're in a microgravity environment. So even though our current spacesuit weighs about 300 pounds, you don't feel that weight. You do feel it in terms of like mass and having to react against that mass. So say you get going really fast, going along the handrails of the space station, and you need to slow yourself down, you'll feel that mass keep going if you're not careful, because you need to react against it to slow yourself down, but the suit doesn't necessarily feel heavy. In comparison, whenever we go to the lunar surface, our suits are going to be a sixth of the weight that they are here on Earth. So that 300-pound spacesuit will weigh more like 50 pounds, and that weight will be distributed between your shoulders and the rest of the suit, because the suit itself, when pressurized, it does hold some of its own weight. It's like the legs are almost like springs that you are helping you to carry that weight around. A lot of our testing we do without weight relief here in our lab, and our suit weighs, without a portable life support system, our prototype suits that we test are about 140, 150 pounds, but doesn't feel that heavy whenever you're walking around, because you have that suit holding up some of its own weight because it's pressurized.
Very cool. Thank you.
Yeah. Okay, so going back, so we had the Mercury, Gemini, Apollo programs. So then we had an architecture change. So the past suits, these suits were all custom, and you wore the same suit for in your vehicle, that's IVA activity, and outside your vehicle, or EVA activity. For shuttle, we were planning missions where we're going to have a lot more frequency, and we also wanted to make improvements on the mobility that you could have in your suits. So the current suits that we have on Space Station and also the future suits are designed with a different architecture. So now we're designing suits to be modular. What does that mean? So that means that instead of being custom made for each crew member, you can mix and match different parts. So we have small, medium, large, extra large legs. We have different sizes of gloves, different sizes of upper torsos. So you can mix and match all those parts together to help fit someone well using the same parts. And that means that they can also be reused by future astronauts. We also have different suits for IVA and EVA functions. Now, this is really important, especially for me as a spacesuit designer, because if you're designing a suit for in your vehicle, you want that suit to be all about crew survivability. So that suit, you don't really need to think about mobility. You're just thinking about sitting in a seat, in their seats that are in their capsule, and being able to survive any kind of accident that happened, like your capsule losing pressure or having a rough landing when you're coming back to Earth. EVA, doing a spacewalk, you want that suit to be very mobile. And we do more mobility by adding different joints and hard goods and bearings that would be bad for that IVA situation. So by having different suits for IVA and EVA, we can optimize both of those functions. And again, IVA is inside your vehicle, EVA is going outside your vehicle. So this is what the current spacesuit looks like. It's called the Extravehicular Mobility Unit, or EMU. If you haven't caught on yet, we like to use a lot of acronyms here at NASA. So sorry, it's a little bit of alphabet soup up here. But the purpose here is low Earth orbit spacewalks. It was originally designed in 1979 and upgraded in 2002, and it's made for movement in microgravity. So that equals a lot of upper body mobility, almost no lower body mobility. So this suit is made for you to move with your arms and not your legs. It's, again, modular, so it fits a lot of sizes of astronauts, and it does utilize a portable life support system, or PLIS. Again, same operating pressure there. We're at 4.3 PSI and 100% oxygen. All right. So this is my favorite part because this is what I get to work on. But what's next? So NASA is planning to do its Artemis missions, where Artemis is the missions where we will launch the first woman and next man to the moon by 2024. And so these missions are really our next step in exploration, where we're going to go back to the moon to learn how to do more sustaining operations. We're also going to explore the South Pole, which is a much harsher environment than the equator, which is where they went during the Apollo missions. And we're also going to prepare ourselves for those Mars missions. So that's really where we're going, is we're going to Mars, but we need to go to the moon first to kind of reteach us how to get there and also develop a lot of new technologies that we'll need for Mars. So hopefully you guys
Chris, before you go too much further, just a quick question. How many layers are in a spacesuit?
Oh, that's a great question. So let me back up my slideshow a little bit. So there is up to, depending on where you're at, 13 layers in your spacesuit. So you have all these layers of multi-layer insulation. So you have an ortho fabric over the top. That's the white layer that we're all used to seeing. And then underneath that, you have aluminized mylar. And you have 6 up to 9 layers of this aluminized mylar, and that's what provides most of your radiation protection and also your thermal protection. Underneath that, you have a nylon ripstop layer that helps to just encase that TMG layer and help protect that overall thermal micrometeoroid garment. See if I have a picture of that. This thermal micrometeoroid garment. Then you have the restraint layer that helps to provide support and shape for the spacesuit when it's pressurized, and then the bladder layer. And this is a urethane coated nylon material. Okay.
Very cool. Thank you.
Yeah. So hopefully you guys can see this video when I play it. But when we go back for lunar exploration and eventually Mars exploration, we want our suits to have more mobility. I want to preface this video with, this is the Apollo suit doing a geology task where they were trying to take a core sample. And the Apollo suit, remember, this suit was made for both in their vehicle and for spacewalks. And so they couldn't have some of the mobility that we're trying to build into the suit right now. But one of the things we want to avoid, see if it will play. Okay, this video isn't playing on this screen for me, but let me see if I can share a different screen. Okay, can you see that?
This is part of the problem solving. Yeah, there it goes.
Okay. So you can see he's got pretty good upper torso mobility there. He's able to hammer pretty well.
I think we may have paused. So if you, maybe we can get a link to that and we can show everybody a little bit later.
Okay, yeah. But in the video, it shows him, he drops his hammer and he struggles to pick it up. He has to take a lot of attempts, and then he just has to go walk and get another tool to pick up the hammer because he just can't bend his knee enough to get down to the surface to pick up his hammer. And so that's why if you look at a lot of the Apollo videos, they have the classic bunny hop across the surface. It's because they couldn't really walk in a natural gait because the suit didn't allow that. It didn't have a lot of mobility in the lower torso. Also, all their tools that they use are on very long sticks because they can't get down to the surface to be able to collect that geology, those rocks. So that's something we want to enable in our next suits. So I don't think these videos will play, but these just show how the future suits, the mobility of them and how they move when we have done some flights in a aircraft that is parabolas that can help mimic that 1/6 gravity that we'll see on the surface of the moon. So then this is the suit that we will use for the Artemis mission. This is the xEMU. So there's lots of improvements with the xEMU. xEMU stands for Exploration Extravehicular Mobility Unit. So we have higher speed data communications. We have high definition video and lights. We have now an informatics display and control system. So we want to do things that can bring in augmented reality into the spacesuit, similar to what we're starting to see in commercial applications here on Earth. We have an integrated communication system, so you don't have to wear your microphone and speakers. Our suit's a lot more automated to help keep the astronauts safer. We have better upper torso mobility, a better outer garment to protect against dust. We have a lot more lower torso mobility to help you walk and do your tasks on the moon, to help make you more efficient. We can go up to a higher pressure. This makes the suit be safer for the crew member. We have a longer emergency return, and we have better portable life support system technology. So this vacuum regenerative CO2 removal system, membrane evaporation cooling, and then our PLIS design is a lot more fixable. We've designed it to be, ORU stands for on-orbit replacement units. So we've designed it for astronauts to be able to maintain their portable life support systems better. And then the suit, the way you get in and out of it is it's rear entry now. So it's easier to get in and out of the suit.
We have a couple questions that came in. So first question, have you ever been to the moon? And then how do they pick astronauts who get to go to the moon?
Yeah, that's a great question. So no, I have not. We have not, I guess, as humanity, been back to the moon since the Apollo missions. So I'm very excited to be able to see humans return to the moon in my lifetime. The way they pick astronauts is they usually pick people from all sorts of backgrounds. You have to have a technical background in science, technology, engineering, or math. So a lot of times these crew members are previously engineers or scientists or doctors. Sometimes they have military experience, like the Navy and the Air Force, especially flying aircraft. Sometimes not. Sometimes they're from research laboratories. And they're all picked because they're very passionate about what they do, and they're very passionate about NASA and human space exploration. I think my biggest piece of advice for people that want to be astronauts is go find something that you're really passionate about, and then get really good at it, and then apply to be an astronaut. There's no one path to get there. You have some people that were researchers in Antarctica, some people that researched the bottom of the ocean, some people that did research in medicine, some people that were helicopter pilots for the Marines, some people that were high altitude pilots for the Navy or for the Air Force. So it's really for people from all walks of life that they choose. And so it's very inspiring. I think that's the best thing, and the most single characteristics thread through all of them is they're all really passionate about whatever they're pursuing. Definitely.
Very cool. While we're kind of talking about how you get to a job at NASA, somebody asked, how did you stay motivated to achieve your goal?
Yeah, that's a great question. So I really, getting to see what they did at Houston and at Johnson Space Center really inspired me whenever I was in high school. And so I kind of held on to that inspiration that I wanted to work for NASA, and I wanted to be an engineer for NASA. And that really helped me get through high school, get through my college classes. And I also was able to have a lot of mentors around me and ask people how they got there. My two older brothers are also mechanical engineers. One went to Kansas State University, one went to Notre Dame, and they had a lot of advice for me to help keep me going, and also help give me the tips to get internships and get research opportunities, and also to do things that would help further my career.
Very cool. Now, real quick, it sounds like the video may have cut out when you talked about the effectiveness of the air tanks. So just real quick, could we answer the question, how long would the air tank be effective? That response, they couldn't hear that.
Yeah, no problem. So the air tank is designed for that 8-hour EVA with some time for contingency. And also we do have secondary air tanks in the suit, in the portable life support system as well. And those secondary air tanks can help provide additional air and support if you start to have a problem with your primary.
Fantastic. Now we had Jerry Dennett ask several questions about the modules for space. So how many modules for the spacesuit are at the space station? Do you allow for damaged modules? And can they be fixed at the ISS?
Yeah, that's a great question. So I'm not as involved in the current spacesuit sustainment, but I do know that they have a lot of different parts on space station. I think there's 3 or 4 hard upper torsos, which is this kind of the center torso of the suit with portable life support systems. And then there's several sizes of arms and legs and boots. And then I believe that before each crew member comes to space station, they send their pair of gloves and probably a backup as well, and bring down the gloves and the backups from the people that were up there. You can do some maintenance on space station. Whenever we've had failures in the past, we've had to figure out how to fix those, because it's very expensive and also could be dangerous to bring down the suits every time that there's a problem. So we do figure out for ways for crew members to fix them. But it isn't easy. The current spacesuit wasn't designed to be maintained on space station. It was designed for the shuttle missions, and it was designed to be maintained here on Earth, because the shuttle would return from its mission every 15 days or so. You had time to do that maintenance here with technicians here on Earth before it went for another shuttle mission. Now we've had to change gears, and we've had to figure out how do you do that maintenance on orbit. And the engineers and astronauts have been very successful doing that. And so we do have kits for them to be able to fix their portable life support systems up there.
Very cool. So why we can, before we continue on with the presentation, Katie is asking how much pressure is in outer space. So that might be a good thing to know why you continue talking about spacesuits.
Yeah, definitely. So if you're out in the vacuum of space, there's no pressure. So all the pressure is provided by your spacesuit. If you're somewhere like a planet that has an atmosphere, you might have some pressure, but where Earth is the only that has enough pressure to be able to sustain life here. We're kind of in a perfect balance of temperature and pressure and oxygen and everything to sustain life really well here on Earth.
Very cool. We had kind of a fun question come in. Have you found another airborne planet?
I'm not super familiar with all the different planetary discoveries. I know that there's been quite a few in the last couple of years. So I probably would defer to NASA's website and for their more planetary science people to answer that question. But I know that there has been a lot of discoveries in planets that might be similar to Earth.
Very cool. And one more question before you continue on. I don't know if you'll know this. You might have to send the question on. But why do they send animals to the moon?
Oh, that's so I'm not sure about animals we've sent to the moon, but I know we do send animals to the space station on a fairly frequent basis. A lot of times those are like spiders or worms or sometimes mice, and we send those animals that way we can understand how they adapt in the microgravity situation. And also we can do studies on the animals that we can't necessarily do on the astronauts to be able to understand science and medical literature about how different living organisms adapt to microgravity. They've done some really interesting experiments on spiders and how they change how they weave their webs in microgravity is different. So that's pretty cool. They've done a lot of different kind of cool experiments with animals on the space station.
Awesome. Thank you.
Yeah. Okay, and so I just have, I think, 1 or 2 more slides here. So we do have, I've talked a lot about our EVA spacesuits, the suits that we wear whenever we go out on spacewalks, because that's what I specialize in, but I don't want to forget about our IVA spacesuit that we're planning to use for our future missions. This is the Orion Crew Survival Spacesuit, or the OCSS suit. Again, for in your vehicle or IVA activity. The reason why it's orange is because you need it to be able to be very visible in case you evacuate your capsule in an emergency situation, so they can see you, for example, in the middle of the ocean or the middle of the desert. Just you want yourself to be very visible. So that's why they use that bright orange. So this suit protects the crew during launch, reentry, and contingency scenarios. It's designed heavily on the shuttle or crew survival suit, and it functions with the Orion system. And it does have more flexibility, and you could do an EVA in the spacesuit if there was a contingency case where you couldn't get into your xEMU, or for some cases, for some missions for Orion, you might not have an xEMU with you. So you do have EVA capability with this suit, but you don't have as much mobility when it's pressurized. All right. So I'll take a lot more or any more questions that you guys have.
Fantastic. Yeah, we did have a question come in. Justin asked, have you read the book The Martian, and how accurate or feasible is the spacesuit technology? So I don't know if you know about the book, but yeah, that'd be great for you to comment on that.
Yeah, so I have read The Martian. It definitely does take some liberties in terms of what could be achievable in a spacesuit design or a habitat design. One thing about, like, when you look at the movie and you look at the pictures of the Martian suit from the movie, is that the material is all very relaxed and it's very easy for him to move in. Where a real spacesuit, you would be pressurized, so it'd be much harder to move, and that material itself would be very taut. So overall, the design of the suit is not bad. It's probably one of the better movie spacesuit designs, because you do have a pressurized volume. He's wearing a helmet. The suit looks similar to kind of what we would use, but I think that it probably is more related to clothing, especially with how he doesn't really have a portable life support system on him, than necessarily what our suit would actually be like.
Very cool. So we have a question about space food. Have you ever tried it?
I have not tried the official space food. I definitely have had some astronaut ice cream, which I've been informed is not really what they send to space station. But space food is what they normally do is they dehydrate normal food. And so it's in a dehydrated vacuum sealed package that then they add hot or cold water to it to help rehydrate their food. They do have some fresh food sent to them whenever there are different missions launched to the space station. Cargo resupplies usually have some fresh food that's sent to them. And they're also doing some experiments with growing their own food on space station. So I think they've grown some lettuce and some spinach on space station. So that's also a way for them to get some fresh food.
Very cool. Next question from Wendy. Is it fun to work at NASA?
Oh, it's really fun. I really enjoy working for NASA. So one of my favorite things is that I get a little part of contributing towards NASA's goal of space exploration and really pushing humanity's their presence in space. And so I love that I get to contribute to that every day. NASA also is a really great culture, really great work environment where we're very supportive and have a lot of mentors and people to look up to. And so it's great. I really enjoy it.
Awesome. Well, I know at the Discovery Center, we talk a lot about the engineering design process and how it's really important to test things, and failure is okay because maybe we learn from failure. So could you talk about the importance of the engineering design process and testing, improving, failure, all that kind of stuff?
Definitely. So engineering design process is very, very important. We use it a whole lot here at NASA, especially in the area that I work in. So again, I work on that xEMU, so the suit that we're developing for the Artemis missions, and our suit is not quite ready for flight yet. So we are getting ready for flight, and the way we do that is we build hardware and we test it until it breaks. We figure out why it broke, why it had a failure, and we fix it, and then we test it again. And so we do a lot of that iterative testing cycles to prove the design works and it's not going to fail our crew members, because it is a piece of critical life support. And so by having that engineering design cycle where you design, test, learn, and then redesign and start again is very important.
Awesome. All right, we have several questions coming in. Emily asks, how many people have been to the moon?
Oh, that's a good question. I wonder if I can do a quick Google search here. I don't know off the top of my head. So only people that have been to the moon went during the Apollo program. It looks like Google is telling me 12 people have been to the moon. The last mission was in 1972.
Awesome. I love that even engineers still have to learn and research things. I think that's really important to show the world, because a lot of the times, engineers are expected to know everything, but they're continuing to learn as well. So that's really important to show. On that, we have a question. What advice would you give someone in high school wanting to work for NASA in the future?
Yeah. So my first piece of advice is figure out what career really excites you in terms of NASA's mission. I'm an engineer that works on spacesuits, but there's a lot of different careers at NASA, not just for engineers. There's lots of scientists that work for NASA, geologists, there's lawyers, there's business procurement folks, there's doctors, there's lots and lots of different careers you can have here at NASA. So if engineering maybe doesn't excite you and get you pumped up about taking classes and going toward that degree, but medicine does, but you still really want to contribute towards NASA, maybe you become a doctor and you specialize in space and aerospace medicine. And there's residencies that you can do that. And then you can work here at NASA and help contribute on the medical side of things. So there's lots of different careers. So I would say research what you could do at NASA and then figure out what makes you excited and what you're passionate about.
Awesome. Now, thinking about the extracurriculars when maybe in younger kids or older, but what classes, camps, clubs, etc., would best prepare you for your job now?
Yeah, that's a great question. So again, I go back to find what you are excited about. Definitely don't go through things just because it checks a box. If it doesn't make you excited about it, then you won't want to talk about it in interviews. You won't get as much from the experience. So if some of the suggestions that I give, if you're like, that doesn't sound great, there's lots of other people who have very different experiences than me. So probably my first piece of advice for extracurriculars is find things that you really enjoy and really like. So some of the things that I did in high school that I think really prepared me for my career here at NASA was, I guess, just one of the probably the biggest ones was 4-H. I was a 4-H'er, so I did a lot of things with the leadership side of 4-H. Went to a lot of camps there. Also did things like crafts and photography and cooking and all things that are not related to like my job at NASA, but it all gave me an opportunity to write about it in my record book and also present projects about it and talk to a group of people. One misnomer about engineers is that we have terrible communication skills and we never need to write things and talk and present, and that's very wrong. I probably do more presenting and writing and emails and reports than I do necessarily hard math and science. And that's because you need to communicate your ideas out to others. And that's the way that you get funding. That's the way you tell people about your design and tell people about your ideas. You have to communicate it. And so those activities that got me communicating with others were very helpful. Also, things like the Cosmosphere, going to those space camps were definitely an inspiration for me, or going to museums like the Kansas Discovery Center and getting excited about math and science and then connecting with others. And then when I was in college, probably one of my best experiences was doing undergraduate research, where I got to learn a lot from people that were older than me, seniors and graduate students that were working on that research, but also got to learn the engineering design process and how to fail whenever you're doing research and learn from it and then start again.
That is so cool. Thank you for sharing all of that. I know there's so many different paths, kind of similar to NASA, that you can go down just for engineering.
Oh yeah,
and that's so cool because engineering is a lot of problem solving, and there's problems to solve in all sorts of different, clubs and camps and everything you do. So problem solving is huge, and thank you for sharing on that. We have a question from Daylin. Daylin asks, how long does it take to put on a spacesuit?
That's a great question. So it depends on your spacesuit, but it usually takes about 15 to 20 minutes to put on, and then it can take longer to then get ready to go out the door on your spacewalk. So if I'm just doing a test in the lab, it probably takes me about 15 minutes to get into the suit and get pressurized and ready to go. But if I'm on space station and getting ready to go out and do a spacewalk, it takes about 4 to 5 hours to get your suit on, get it checked out, and then get ready for that spacewalk. So it depends what situation you're in.
Awesome. All right, Rick has a question about our current situation in the world. Will you have to work at home or shut down NASA because of COVID-19?
Yeah, that's a great question. So I am working from home. I'm coming from my house in Houston, Texas for you right now. I put my dogs in a couple rooms over so that way they didn't interrupt our presentation. We didn't necessarily shut down NASA, so there are still mission critical folks that are going into work, mainly those that are supporting the International Space Station. So flight controllers that you see in mission control are still going into work, and people that are getting ready for upcoming flights. Because the xEMU is not slated to fly until 2023 and 2024, 2023 first to space station and 2024 to the moon, we're considered non-mission critical, so we're all working from home at this point.
Awesome. Thank you. So we have a question from Barbara. Have you ever been to a space camp, and what's it like?
Yes. So I have gone to the space camp at the Hutchinson Cosmosphere. There's lots of different space camps all across the country. I think one of the most famous ones is out of Huntsville, Alabama. They have a space camp there. So my experience at space camp was that, one, I loved it. It was a lot of fun. And two, we got to do a lot of problem solving and critical thinking projects while we were there. So we had Lego design challenges where we built Lego rovers and had them go through obstacle courses. We had missions that we had to execute and design and practice on communication skills and science skills and all those things. And then we learned a lot about NASA, about planets, about science, about careers that you could do to get to work for the space industry. So yeah, it was a great experience. I definitely would recommend it. And there's a lot of camps out there that offer similar experiences.
Awesome. Well, we had a question come in through Messenger. When did you know you wanted to be an engineer?
So I think I knew when I was about a freshman, sophomore in high school, whenever I got to do that experience, going to the space camp at the Cosmosphere, I learned about all the different cool opportunities you could have in engineering. And that also was at the time, what I found really cool in terms of being able to work at NASA was to be an engineer. I also was probably a little bit influenced by my two older brothers who are also mechanical engineers. So I got to see what they were doing. And I thought it was pretty cool. So that's when I really decided I wanted to do engineering.
How fun. Wendy asks, what do you like about NASA?
So probably my favorite thing about NASA is just the fact that I get to contribute to humanity's drive for space exploration, and I get to contribute to new technologies like the spacesuit. So, and I really love the mission, and that inspires me to go to work every day.
That is awesome. Now, I know there's a lot of young girls out there who might think math, science are a little too hard or things like that. You went through engineering, we both did. What advice would you give to young girls who, are thinking about engineering or a STEM field in general? So advice for young girls, what would you give them?
Yeah, so I guess my first piece of advice is one, that they can do it, to not be discouraged, so that that's what they want to do, that they should absolutely pursue it. And two, that it won't always be easy, that there are going to be times whenever that it's difficult, either because of the class that you're taking, or maybe there's just different situations where you're going to run into some roadblocks. And so the biggest thing that helped me get through those roadblocks is finding other people that could be mentors, or could just be kind of peers with me to get through that class, to get through a project, to help keep me on the path to stay in engineering. And so by finding other mentorships, that really helped inspire me to stay in engineering. One of the biggest ones was Society of Women Engineers. And when I was at college at K-State, it was a group of other female engineers that were experiencing the same difficulties I was. And so by having that group of people around me as a support structure, it really helped keep me in engineering.
I absolutely loved that group when we were in college. There's so many people, just like you said, who understand what you're going through and the problems, that arise. So that's really cool. And it's also, I noticed in our world, engineering world, we always work in teams. And so I know that having to seek out those mentorships and clubs and that support system really helped me through the teamwork aspect of engineering as well, because it helps you realize that, great minds, two minds are better than one, three better, two, those kind of things. So it's really fun to hear you talk about teamwork and the importance of that, especially for different reasons there. So we have more questions coming in for you, lots of interest. Let's see, how many different types of spacesuits are there?
Oh, that's a great question. So there's probably only 4 or 5 types of flown flight spacesuits. So you have your Mercury, your Gemini, your Apollo suit. We had a couple different configurations of the Apollo suit, and then you had your shuttle spacesuit. So we have our flown spacesuits, and then we have a whole variety of prototype spacesuits. And so prototype spacesuits are suits that we've designed and made just for the research aspect of how do we build the best spacesuit. And so those suits, we probably have 12 to 15 or more. And there's also private companies and universities that are also making prototype spacesuits. So there's been lots of different, again, going back to the engineering design process, lots of different spacesuit designs that have been tried over the years, and different prototypes that have been tested. And so we're always learning. So hopefully we have the best spacesuit whenever we're building our xEMU. And then we'll continue to have prototypes and continue to build new designs, so that way maybe the Mars spacesuit or beyond is even better than that.
That is awesome. Well, I'm going to tell everyone we're going to wrap up here shortly. So if you have any last minute questions, be sure to send us a message or comment. But we have a question. I know you talked about all the different kinds of jobs that NASA has. Specifically to engineers, how many engineering teams work on one spacesuit?
Oh, that's a great question. We have a team for the we break it into hardware parts into 3 different teams, and then we have teams of systems engineers and project management that helps us pull that all together. So the 3 main hardware teams for the suit is the pressure garment system. So that's this group that I'm in, and so we work on the design of the suit that the person is inside, that's moving. So that's the you're going to think about it kind of basically, that's kind of like the clothes of the suit that gets pressurized. And then you have your portable life support system. So that's the backpack of the suit. So that's got everything in there to keep you alive for those 8 hours during your spacewalk. And then we have another team called the informatics team. And so that team is all kind of the new technology that we're putting in. So like augmented reality we're trying to put in, having better caution and warning systems, lights, cameras, things that will hopefully continue to improve as the suit is developed. So those are the 3 main hardware teams. And then above that, you have a systems engineering team that helps us put it all together and helps us coordinate between the groups. And then a project management team that then coordinates with people outside of xEMU to help us get us money, help do the schedule for the project, all those things that you need for project management.
Awesome. That is so cool. Well, if anyone has any other questions, feel free to comment, send a message, and we'll do our best to get them, get an answer from Chris and see if we can get those answered for you. So we put a link in the comment section. It's nasa.gov/suitup that Chris mentioned here. So if you have any other questions, definitely check out that NASA website. Email us, let us know, and we'll see if we can get an answer from her about any other spacesuit questions and engineering in general. So we thank you, Chris, for being here. And we'll let you know if there's any more questions that come about. But thanks again. And if you have any last words to share with our friends, we'd love to hear that.
Great. Thank you so much. I just really appreciated this opportunity to talk to you all. Thanks so much for the great questions, and hopefully I can answer some of the last minute questions people send in. And thank you, Caitlin and Laura for setting this up for me.
All right. Thank you so much. And we'll talk to you again soon sometime. So thank you so much and take care.
Bye.